have here?
Standard 1144. Owner called it in. She claims it was like this when she got here. She's over there questioning.
Do you have anything more?
Photos?
Well, what is it?
The contents of the jar?
No, what is it?
Nematodes?
No, what is it?
C. elegans?
What is it?
Dead worms.
I'm gonna need more than this to go on. Grab Nielsen, find some expert. Learn all you can about worms.
But why? This seems cut and dry. Natural causes.
Simple. Because some early bird got this worm. Damn.
Hey.
Quick, have you been diving in fly medium again?
No, but you told me to learn everything that I could about worms, and
you did this by going and digging behind the lab?
Maybe.
Did you at least talk with some expert as opposed to Mr. McGregor?
Yeah, no, he told me all about it. See, there are 5 main mechanisms that...
First, get a towel.
The first form he told me about was ionizing radiation. It can take the form of X-rays, gamma rays, or UV light. This leads to double-strand breaks, which can then lead to gross chromosomal rearrangements. These rearrangements can take the form of translocations, in which non-homologous chromosomes exchange information, inversions, which are interchromosomal rearrangements, in which we end up essentially switching the order of genes, and indels, or insertions or deletions, in which we end up with either too many or too few copies of a gene.
So what about chemical mutagens? They can be traced back to World War I and II, where we were used in chemical warfare. Often these are alkylating agents, like ethyl methylsulfonate. As you can see, these can lead to point mutations in future DNA strands. So what's next?
Transposons. But can we just get an intern to do it?
Sure.
Intern!
That was pathetic.
Yes, Miss Kirk? What do you want me to do?
Explain.
Okay, transposons. So, transposons, or transposable elements, have known sequences. Typically, they cause recessive loss of function mutations, but they're limited by the enzyme transposase, which allows them to move. Within most genomes, there are hotspots for these, in which transposons can move freely. As you see, transposons affect genes differently based on where they insert.
It also could be targeted gene-specific mutagenesis. This method of mutagenesis uses homologous recombination to perform an allele replacement, like this. Also, it could be RNAi, otherwise known as RNA interference, and this introduces double-stranded RNA into a system of cultured cells. The double-stranded RNA is processed, and then it can be fed or injected into model organisms like Drosophila or C. elegans. The little strands of RNA degrade mRNA within the cell, which interferes with protein synthesis. This leads to a phenocopy, or a loss of gene function, or a null mutation that doesn't change the genotype.
Praise.
That was really, really good. So, I got results back from the lab. What we know is the worms all have the same genotype, and all of the worms had given birth to offspring successfully. So, we know it was mutagenesis.
I suppose that rules out ionizing radiation. They all have successful progeny.
Well, that would also rule out chemical mutagens, right? Because we didn't find any SNPs or anything, so if there was a point mutation, that would rule that one out.
True enough. Rule out targeted gene-specific mutation because they all had wild-type genes.
And the lab did a test for common transposable elements and didn't find any, so I don't think it's transposable. Oh!
And that leaves RNAi.
Well, I remember that C. elegans especially, if they eat bacteria that have been treated, then they can actually be subject to RNAi.
Let's go back to the scene of the crime. Alright, We swab everything. We're looking for bacteria that may have been modified to contain RNAi.
I swabbed everywhere, all the other rooms, including the handle and the outside of this weird bucket I found in the closet.
A bucket of what?
I don't know. It just said RNA to be used for RNAi in C. elegans with the something 3 gene? Could that be a clue?
Did you bring the bucket?
No. Should I? Oh, okay. I'll just maybe go get that then, sir.
Print. Bucket. Now.
Sorry. So you were pet sitting, correct?
That is correct.
And do you like nematode worms?
Of course, who doesn't? They are so round and funny looking.
Have you cared for C. elegans before?
Yes, I am a professional worm breeder, as it were. I have won several prestigious awards.
And you had nothing to do with their death?
Of course not. They are, so making me the money, as you say.
So, can I have a fingerprint?
No, of course not. I am not some stupid American criminal. No, get that away from me. Now, I must go. My mustache needs waxing.
Well, would you like a glass of water before you go?
Of course, I never want to turn down free hospitality. Now, au revoir, Felicia Hare.
Wow, is he dumb? So, the prints from the bucket and the prints from the pet sitter's water glass. That looks like a match.
Yes, my plan is complete. I will never know it was me. It was perfect. So,
Mr. Paul E. Murray's.
it's Paul E. Moraes III, you swine.
You are under arrest for the possession of a bucket containing E. coli specifically engineered with RNAi to kill C. elegans.
You have no proof it was me.
We have your fingerprints from the bucket.
But how? No!
It looks like he couldn't worm his way out of this one.